Hello, everyone. Good afternoon to all of you, and good morning if anyone outside the geographical domain of India or somewhere else. My name is Dr. Kamal. I'm pleased to do this webinar for the Energy Management System, Smart Energy Planning, Operation and Control. Actually, this presentation, I think it's sort of like summarize about maybe 30 years experience of working with various utilities, vendors, consultants about the energy planning, operation and control. And in fact, you may be sort of like wonder what's the importance of this. If you check in any place in the world, there is the utility business, which is energy production. It's existing in every country in the world, and there is a task for this utility is to keep the lights on. And who is doing this? Smart engineers who are working 24/7. So my presentation outline today is going to be sort of like I will brief you with a holistic typical energy sector structure, which is it's going to be similar in Europe, Asia, America, Middle East, everywhere. And then I will brief you with the strategic goal of every utility, which is keeping the lights on through continuously balancing the generation and demand 24/7, 365 years. And I will brief you as well, how do they achieve the above goal? Of course, I will go through the 4 levels of controls. The first one, which is the primary control, which is the Droop. I will brief you with what is it, what that means. Secondary control, which is automatic or remote generation control. Tertiary control, which is dispatch, and scheduling control, which is unit commitment. And at the end, I will tell you where this experience can good and can help you to improve your career and find opportunities in this area. By the way, if you look for any countries, for example, if you go to Middle East, Europe, UK here, you will find, for example, the business of the energy, it maybe have about not less than 40,000 staff working in the business industry of the energy. However, it may be more than 20,000 of those staff, they are working in this area, which is generation, planning, operation, and control, as well as the market. And at the end, I will tell you what is the firms and the companies who involve typical names of the name of companies who work in this field. So just sort of like a holistic overview, if you can find, if I start on the left, you will find on the left, there is the generation companies, which is they are sort of like either state, belong to state, or independent power producers, which they are doing commercial with trading with the energy. And as well, there is something related to the renewable, which is renewable energy sources, RES. And if you find there, sometimes you'll find have an embedded generation, which is small generators like wind turbines, solar are connecting to the grid. So this is on the left, which is, we call it the production side. On the right, far right, we have the distribution companies, which is bring the energy to your homes, your factories, big customers. So it's like in the middle, you will have something called a transmission company, which is sometimes we term it as TSO, which is transmission system operator. And below it, you will find the interconnection with other utilities and large customer. All this sector, which is generation, transmission, distribution, large customers, are controlled by authority in every country called a regulator, which is oversee the activities, the license, and regulate the license activities of every individual stakeholder in this structure. This is an overall holistic typical energy sector structure. If I'm looking at typical names, as I summarize it with energy sector players, there is the first is the power producers, second, transmission system operators, TSO, and then energy market operator, who is responsible for energy trading and exchange. We have distribution companies, we have suppliers, we have regulator overseas and control the license and the policies. And the most important is customers who are consuming and utilizing this energy, which is you and I, our homes, our factories, and so on. Okay, so if the basic thing which need to be done, which is we have like balance, we have to keep a balance between the load and generation 24/7. So when the generation and the load are the same, we will find the frequency will always be 50 hertz or 60 hertz. However, when there is imbalance occur, if the generation is over the load, it's going to be more than 50 hertz, and this is this impact on the stability of the system, and it could be cascaded fault or shutdown, as well if the load is higher than the generation, as well again, there will be a problem in the system. So we need to keep the load and generation 24/7 as balanced the same all the time. So when load is vary all over the time from the morning until the evening, until the midnight, the generation has to follow the load. So this is the basic thing we are looking for, which is balancing the generation and the load. So the impact of imbalance between the generation and the load is going to be devastating for the system. So we need to keep the balance so that we'll keep, because any changes, any imbalance, it will be impacted on the frequency. So the load vary continuously in more or less random manner during the day, and the system frequency vary accordingly. If the load is greater than the generation, the rotating mass will be decelerated and the frequency will decrease, and vice versa. And just to give you like how serious the utilities and the business looking at this issue, it takes a few seconds that imbalance between the generation and the load will occur, and the whole system will collapse, and the whole country will go into complete blackout. And this is what's happening when we hear sometimes there is sort of like blackout occurs in India, blackouts in Pakistan, in Middle East, in America, in some European countries, because there is imbalance between the generation and demand. How do these guys? They have to improve this and make sure that always there is a balance, and they have to take care about emergencies if the imbalances occur, what they will do. So how we achieve this? We achieve it with 4 levels of control. I will go through all of them in a little bit detail, and I think it like each one of them, it needs sort of like more than 2-3 lectures to cover it, but I will try to to give you an idea how this happened, how the engineers in the control center, because every utility has a control center, for example, transmitter or transmission operators, who is controlling the balance between the generation and demand. So they do it in 4 levels, which is, the first one is the primary control, or sometimes we call it drop setting or governor action. The second one, which is the secondary control, which is automatic generation control or remote control of generators. And we have the 3 and 4th, which is coupled together, which is tertiary control, which is economic dispatch and scheduling dispatching. They are doing it. and each control cycle, it follow certain domain. This will be clear in this diagram. If you look at this one, if you start from the bottom, which is the far left bottom, which is you find PR, which is the primary control, which is the control the generation with from 0 second to 30 seconds. And this is happening automatic and without interference of engineers, but with the design of the system. So if there is any disturbance occur, there is some automation in the system occur. And to improve this, for example, if there is imbalance that the load is higher than the generation, the system inertia occur, and then the generation will be automatically increased without interference of the engineers. By the way, it's designed on the first time, and it will try to improve it. So the first one is the primary domain, and it will be from 0 seconds to 30 seconds. Then after that, this primary domain will be coupled by the secondary control, which is the second one, which is the secondary control, which is ADC domain, and sometimes we call it LFC, which is load frequency or secondary control. And this is, of course, between say 30 seconds and 1 minute. So this action is used as automatically and programmed by engineers. And the third one, which is economic dispatch or tertiary, which is based on 5 minutes to 15 minutes, and the other unit commitment is from 15 minutes to 1 hour. So this is this one by these 4 control or management steps, we manage to keep the balance between generation and load. And by the way, this represents the about 50% of the jobs of the control center of utilities. Because if you go to utilities control room, you will find there is something called transmission desk, a transmission desk operator, and beside it, there is another desk called a generation desk operator. And that generation desk operator, which is work 24/7, it follow these 4 control cycle. And this generation desk, by the way, it has maybe 3 engineers or 4 engineers, but that is supported by a team normally more than 50 or 100 engineers who are planning, fixing, putting the tools for these control cycles. Okay, I will do here, I will go through a little bit of detail of each one for the primary, secondary, tertiary, and then we'll check what will happen, just detail, a little bit detail of this, so to give you a flavor of this, so that you will be able to understand how those people in the utilities they are working. So I will start first by the primary domain, which is, if you notice, I have stricken the 3 levels and focus now on the primary domain, which is 1, which is the primary domain. Basically, if you look at any generators, you will have something called turbine government, and basically, there is something called load reference. So there is a sensor with the turbine governors, so that when there is a frequency variation occur, when there is a frequency up and down, which is the delta frequency, it will impact on the steam or the gas flow coming out of the turbine government and governor. So the turbine governor will go up and down, and it will impact on the active power, and there is feedback on the amount of active power going out from the generator. And this is going to be in a closed loop control cycle, and it's happening all the time. If you notice, there is a comparison between the load reference point and the active power, and the main input of this is the frequency error. This can be detailed in something like this, which is the generation primary control. If I look at F as the nominal frequency, which is the steady state, which is if node, if I say 50 or 60 hertz, okay? And when there is a frequency variation occurs, well, sorry, when there's frequency drop occur like this, the primary control will increase the output of some generators based on their drop setting, and it will bring it back to a nominal value, which is 50 or 60 hertz, which is a quasi steady state deviation. Okay, if you look, just this is now, I'm focusing now in one typical generator. The red line here, I called it the slope or the droop of each generator. Each generator, it has a droop and it has sensitivity. So when any generator power station feel that a frequency has gone down, it will respond automatically by a certain amount. So if I have the delta F, when the frequency is going down, you will find the power station, the power output will go from P2 to P1, increased in this case. So when the frequency is going down with the slope like this, so delta F here, by delta F, the power is going from P2 to P1, and vice versa. If the frequency goes up again, then this means that we need, the generator will decrease the frequency automatically, and it will move from P1 to P2, and so on. So this is what we call it, the speed or a droop. So a droop, we say, for example, a droop of generator is set as 0.05%, and this is the equation, which is delta frequency over delta power. So the variation of frequency, how much it will result in generator will change its output automatically by delta B. This is shown in, for example, if I have two generators here, generator 1 and generator 2, and if you notice, I have different droop setting, and with the same frequency, you will find the generator 1 or unit 1 when the frequency changes from the orange slope to the green slope, and when the frequency with the same change from orange to green slope, you will find that like all of them crossing the nominal frequency, which is F node. If you notice that, for example, the generator 1, they will respond with from P1 to B2, the variation. Look at the distance between B1 and B2, which is the variation of the power, and look at here, in this case, B1 and B2. So when the frequency, like, all depends on the droop setting or the slope of each generator. So each generator is when they design it, they put gauge on it to control its response, its automatic response to frequency variation. And this is, by the way, its agreement occurs between the generator and transmission system operator, and normally this come under something called ancillary services, where when generator is providing this service to the grid, normally they have paid them for this service. Imagine that the frequency is changing all the times, every minute. So the generator as well, it's keep changing with the frequency. So when the frequency is down, the generator automatically will go down. We speak about domain sometimes here of 500 milliseconds or even less. Okay, so I will move now from the secondary, like this primary control is coupled with automatic generation control, and sometimes they call it secondary control. So the first one we call primary control. The second one is called a secondary control, which is ADC or LFC secondary control. What ADC is doing, basically, the generator is controlled remotely by the transmission system operator control center. It's like how they do it. Once they put the generators on the remote control, it's like the power station, eventually they don't have the control on their generator. However, they can take over this control any moment they wish, but normally they give it to be controlled remotely. And what it will do, it will coordinate the variation of the frequency in the system among the whole generator in the system. So, and this will be done through the program. It's called automatic generation control, which is produced by many vendors, and most of the utilities have that program, which is control the frequency close to 50 all the times. However, like as I told you, the automatic generation control is controlling the generation within 1 minute or 2 minutes domain. The primary control, we speak about first 30 seconds. So the faster response is the primary response, but however, the primary response is doing it randomly without any efficiency picking of the generator. So like when there is variation in the generation occur, imbalance between the load and generation, I need to pick up the most efficient generator in the system rather than doing it in random way. And this is the job of AGC. So AGC is picking up the right, most efficient generator to change its output to regulate the frequency and bring back the frequency to 50. So what the AGC is doing, this is, we say that AGC works as a secondary centralized controller existing with the transmission system operator control center. So it's all of it based on allotting the load variation to a number of units contributing or sharing the AGC automatic generation control, and all of it based on some idea called ACE, which is area control error. So area control error means the megawatt imbalance occur due to the frequency changes. So when the frequency, for example, goes to from 50 megahertz to 49.9 megahertz, then sorry, from 50 hertz to 49.5 hertz, this will reflect in a deficit in the generation called ACE, which is area control error. This is in case of down direction. So this means that when the frequency goes to, say, 49.5, this means that some utilities mean that I need 50 more or 60 or 70 megawatt, and vice versa as well. If frequency goes up, this means that I need to decrease the system by certain amount of megawatt. Okay, so this is the secondary control. So if you look at this, this is as well, we are looking at 50 hertz, and when there is frequency is going down, when the frequency is going down, the automatic generation control will instruct the generator automatically to increase its output and to this level here. And then after that, this is the job of the primary control. So if you notice that the tuned one is the primary control, which is small variation. However, when there is bigger variation in the system, we need an automatic generation control.